Okay, grab those geobooks. Let's start talking about similar triangles. Video 16. Okay, first thing we need to talk about is what happens when triangles are within other triangles, like this. See this triangle, this smaller one, is inside this larger triangle, ABC. Well, when that happens and the two sides here are parallel and they share this angle, turns out that the two triangles are similar. They're similar. So when they're similar, we're going to use proportions to try to solve for missing sides, like we have been. Okay, it's just now we're going to see the triangles set up a different way where they're embedded in each other. Okay, so I'll show you how to solve those on the next page. Okay, be sure to write the title of your notes, the directions, and draw this picture. So pause the video and get all that written down. Okay, so notice that we have a triangle KMR, inside of triangle DAR. And we have to try to find this length right here, side KR. So in my opinion, the easiest way to do this is to take the two triangles and draw them separately. And then we'll solve them the way that we have been solving for missing sides, by using proportions. So we're going to draw, I'll go ahead and draw the smaller triangle first, which is KRM. And then I'll draw the bigger triangle. And that's going to be triangle DAR. Okay, now we need to label the side lengths so that we'll know how to which numbers to use for our proportion. So if we look here at the little triangle, the two sides that were given would be KR and MR. So KR is Y and MR is 14. So I'm going to go ahead and write those in. So KR is Y and MR is 14. Okay, now let's look at the bigger triangle. Let's look at side AR. What is the length of the entire side? Well, it's not 14, that's this length. And this from here to here, AM, is 16. I need the entire thing. So I need from here to here. So that we're going to have to add the 16 and the 14. So that side is actually 30. So I'm going to put 30 right here. Okay, now let's look at side DR. Well, DR is not 11, and it's not Y. It's the sum of these two. So these two would be Y plus 11. Now I can't combine those and get 11Y. That's multiplying. Okay, they're not like terms, so we're going to have to keep them separate. So we're going to put over here Y plus 11. Okay, so now we're going to go back and do what we've been doing in the previous section. We're going to use circles and rectangles, find the similar sides or the corresponding sides, and then set up our proportion. So this side, side Y, what side do you think that goes with? What side do you think is similar to it? If you are thinking Y plus 11, you are correct. And then 14. Okay, this side is similar to this side. So we're going to put a box around 30. Now we go ahead and set up our proportion and solve for y. So I'll start with y over, now if I use this one, I'm going to have to put this one below it, y plus 11 equals, and then we'll use our rectangle, our rectangles, so it'd be 14 over 30. Okay, so now we need to cross multiply. Okay, so we're solving like we have been. So y times 30 would be 30y equals 14 times y plus 11. Okay, so now we have to distribute the 14 into the parentheses. So we end up with 30y equals 14y plus, now I just need to use my calculator to figure out what 14 times 11 is. So let me put that in. We end up with 154. Okay, next we want to get our variables to one side, so I'm going to go ahead and subtract 14y from both sides. This will cancel. We end up with 16y, 30 minus 14, equals 154. Okay, now I need to divide by 16 on both sides. And y is going to equal whatever 154 divided by 16 is, which is 9.6 when I round to the nearest tenth. Okay, so let me go ahead and put a box around my answer. And we solved for y. Cool. Let's try another one. On to problem 2. Okay, so I don't know if you see it or not, but there are two triangles here. You have the triangle that is formed with the flag here, and probably the shadow of the flag. And then we have this little guy here. He forms another triangle with his height and probably his shadow. That's my guess. So what we have to do is find the height of the flagpole. So I'm going to go ahead and put an X there so I know what I'm looking for. Okay, so just like the last problem, we need to go ahead and draw our two triangles. So we're going to separate them. So I'll draw the small one first, and then I'll draw the bigger triangle. And then we label the sides, we set up our proportion, and solve. Okay, so the smaller triangle, the sides would be, this length here would be 6 feet, and down here, 10. So we're going to go ahead and write that here on the smaller triangle, so 6 and 10. And then the bigger triangle, we're working with X, and we have the entire length here of 85 feet. So we're going to put X here and 85 here. Okay, this problem's actually easier than the first problem, so that's cool. All right, actually before I set up my proportion, I should circle the similar sides. So I'll put those two together. Those two are similar. And the 10 and the 85. Okay, we are ready to set up our proportion. So I will start with the circles. So 6 over x is equal to, I started with a smaller triangle first, so I have to work with the smaller triangle first on the second fraction. So it'd be 10 over 85. Okay, next step, we need to go ahead and cross multiply. So here and here. So we end up with 10 times x, or 10x, equals whatever 6 times 85 is. I'll just punch that right into my calculator. 85 times 6 is 510. So 10x equals 510. Next step, divide both sides by 10. And we end up with whatever 510 divided by 10 is, which is, you guessed it, 51. So the height of the flagpole would be 51 feet. And I'll go ahead and put a box around that. That was way easier than the first problem. I like it. Cool, let's try one more. Okay, problem 3. So it's the same idea. Another triangle inside of another triangle. And this time we are looking for the length of the shadow of whatever this is that's 6 feet tall. Okay, so this whole thing, or actually from here to here, is 30 feet. And we have to find the length of the shadow. That's going to be a little more challenging, but we can do it. How about we go ahead and put an X where we want to, for what we're looking for, which would be the length of the shadow. So we'll put an X there. Okay, now, just like before, we're going to go ahead and separate the two triangles. So I'll start with the smaller triangle, and then I'll have the bigger triangle. They don't have to be perfect. Okay, and we'll label the sides that we know. So if we look at the smaller triangle, we have 6 feet here, and here we have no idea. So we're going to put an X. So 6 and X. Okay, now for the bigger triangle, we know that the height here is 20. And what about this length here? I don't just want to go from here to here. I don't just want to write 30. I need the entire length because that's the whole length of the bigger triangle. So let's see, I have 20 here, and we need to figure out that bottom length. Well, we know it's 30 plus whatever this piece is. So we're going to have to just keep them separate for now. We're going to write X plus 30, just like the first problem we had to do. Okay, well, now that we have our sides labeled, let's go ahead and circle the similar sides. Put rectangles around the other similar sides. And we're ready to set up our proportion. So we'll start with the circles first. We're going to write 6 over 20 is equal to, we started with a 6, so we have to start with the X, the smaller triangle, over X plus 30. Okay, we can cross multiply now, just like we have been. And we end up with 20 times X, or 20X, equals 6 times X plus 30. Okay, next step, distribute the 6 in to the parentheses. So we end up with 20x equals 6 times x, which is 6x, plus 6 times 30, which is 180. All right, now we want to get our x's to the same side, so I'm going to move the 6x by subtracting it on both sides. It will cancel here. We end up with 20 minus 6, which is 14x, equals 180. Okay, next step, we need to divide both sides by 14. And I'm going to use my calculator again to divide 180 by 14. And I'm going to round to the nearest tenth, and I end up with 12.9 feet. for x. So we have the length of the shadow as 12.9 feet. Cool. Okay, well, I hope you understood that. If not, we will answer questions in class and we'll practice more in the next few days. Have an awesome day.